Good morning. Welcome to the masterclass lecture on machine-to-machine connectivity and its applications. This event we are doing on the occasion of Azadi ka AmrutMahotsav. We are celebrating this 75 years of India's independence. For that reason, entire India, we are doing a lot of events related to this Azadi ka AmrutMahotsav. For any kind of support or collaborations, please contact Mr. Prakash Vinod. He is the center head for smart manufacturing and precision machine tools. Sushma, whether my voice is audible? Is it audible?
Audible.
Yeah, thank you. Yeah, as I mentioned, the topic is machine-to-machine connectivity and its applications, mainly to metal cutting machines. Myself, Narendra, I'm working as a scientist in Smart Manufacturing and Precision Machine Tools department at CMTI. Going forward, these are the contents I'll be presenting today about short introduction about CMTI, then what we are doing in Smart Manufacturing and Industry 4.0. We named the department as Smart Manufacturing Demo and Development Cell. It is a part of Samarth Udyog Bharat 4.0 initiative. And then as this machine-to-machine connectivity is a very small topic in smart manufacturing, I would like to just introduce the smart manufacturing technologies so that you can able to get the relevance of machine-to-machine connectivity. Then I'll be giving basic introduction about machine-to-machine connectivity. Then what are its applications in manufacturing industries? And then there were some requirements from the industry participants that they wanted to understand the data flow. And then we'll also demonstrate a few solutions, how we could able to convert the data into an applications. With this, I'll start my presentation. I think there are new participants from various organizations. First of all, I would like to tell about CMTI. CMTI is an autonomous R&D institute under the Department of Heavy Industry. CMTI, we generally we have expertise in developing special purpose machines, and whatever projects we take, sometimes we take a national important, whichever projects we take, some are national importance. And then the facilities what we have related to advanced manufacturing, nanotechnology, then sensors and vision development. Srihari sir, can you please mute yourself? I request all the participants, please mute yourself. While joining also, sometimes this noise will come. CMTA, we have state-of-art laboratories on nanotechnology, sensors and vision department, the vision developments, then advanced manufacturing labs we have, and we provide services to from multinationals to academics. We provide services, and we have another department called as Academy of Excellence in Advanced Manufacturing Technology, where we do skilling and reskilling for industry people as well as to the students. That is a very short introduction to CMTI. I'll get into the second topic, that is a Smart Manufacturing Demonstration and Development Cell. This is an initiative by Department of Heavy Industry. They have created a program called as a Samarth Udyog Bharat 4.0. There are about 5 centers who are working on this Smart Manufacturing and Industry 4.0. One is the IISc Bangalore, IIT Delhi, IIT Kharagpur, CMTI, and C4 I4 Pune. Okay, I'll be talking about CMTI SMDDC, that is a Smart Manufacturing Demonstration and Development Cell. As the name says, that we need to demonstrate about smart manufacturing and industry 4.0 solutions to the industry professionals, even to academic institutes, to know about the technologies, so that because the requirements and also the demand for this for Indian industries is huge. For that reason, government is stressing a lot on awareness programs. That's why we are conducting series of events on this area. And then, as the name says, we are also working on development of low-cost solutions for MSME industries. Whenever we talk about Industry 4.0, most of the time these MSME industries think about return of investments on the value what they invest. For that reason, we are trying to develop some low-cost solutions which can get into their factories because of the advancements in electronics and the computer science, open source programming languages. People are comfortably making low-cost solutions. Even we also are developing few solutions we'll be showing at the end. Then what we do in a smart manufacturing demo and development cell. Basically, we are working on 6 activities. One is Industry 4.0 implementations. Then we are working with industry collaborative projects. And then we are establishing a smart factory. And we do training and awareness events. And we also develop some solutions. Whichever solutions are deployable, we try to sell those technologies to industries. Okay, those who are planning to implement these solutions in their factory, they will be knowing some of the implementation challenges. Okay, also in CMT. Mr. Raju sir, please mute yourself. Yeah. When it comes to implementations, I think some of the manufacturing industries, they would have faced the challenges when implementing. What here in CMT also, whatever labs we have, we try to buy the ready-made products which are available in the market, and those products we'll try to implement and see the challenges what we face. Okay, for that we have implemented few solutions related to Colsize, Bosch, and MaxBite. And then coming to industry collaborative projects, we are working with the 6 industries, that is HAL, Siemens, IMTMA, Acumac, Utunga, and Hexagon Metrology. And with coming to a smart factory, we are trying to establish a workable smart factory. Hope now it is under progress. We have bought around 3 machines, and hopefully in the coming 2 to 3 months, we'll have AGV, robot, all that will be installed. By March 2022, this factory will be functioning. I request all the people to come and have a look at smart manufacturing. Then you can have a real feel of smart manufacturing. And as a part of training and awareness, we are conducting today's event similarly. And I will be not talking much about R&D projects because that is not of our interest now. Coming to the industry partners, what exactly we are doing is we are working with Utunga Technologies. This is a software-based company. They would like to develop solutions to manufacturing industries with their software development team. For that, we are working on IoT-enabled technologies and machine connectivity. And the second industry, that is an Acumac, which is a SME, small and medium scale enterprise, where they are developing spindles. They make thousands of spindles and supply to the machine tool manufacturers, OEMs. And they, in order to be globally competitive, they wanted to make their spindles as smart spindles. We are working for making the spindles into smart. And the third industry is Siemens. In Siemens, we are working on digital twin based availability prediction for spindle and feed drive system. Here, the essential thing in Siemens is their products are used in most of the sectors like food processing, even manufacturing, automobile. Those guys wanted to have complete control on failures of their products. For that reason, the data is the key for them. In order to generate the data, we are trying to develop a test rig wherein they can get the data. With that data, they will be developing the modules like AI and ML, artificial intelligence and machine learning models. In turn, that can be used for digital twin. And then with the HAL, it is basically a social, corporate social responsibility event. They wanted us to help all these academic institutes and even MSME industries to get trained in this smart manufacturing and industry 4.0. There will be doing mostly hands-on sessions, and in the coming months we will be calling all of you for joining hands-on sessions. Most of the events would be free. Sometimes it will very nominal charges will be taking from this. And with Hexagon, we wanted to make entire our smart factory, our manufacturing workshop into a smart workshop. We collaborated with Hexagon Metrology and this Indian Machine Tool Association, Manufacturing Association. They also are working with us for a smart factory demonstration, because under them a lot of machine tool OEMs, even users are connected with them. They wanted to penetrate this technology to their users. For that reason, we collaborated. We both are working together. And those who wants to feel how the smart manufacturing looks like, how the smart factory looks like, you can have a look here. You can see the raw material is coming from outside with the help of barcode. This AGV will be pick that component and takes across the factory. This automated guided vehicle will be going across all the machines in this factory, both metal cutting machines, then laser processing machine, then we have measurement systems. And these robots were used for machine tending, where pick and place it will be doing it. And once the component is finished with all the manufacturing processes and measurements are done, it will go to unloading station. From there, it goes to the customer. This is how the entire factory has been planned. Here, one thing you need to see here is these machines are not, they are not just doing their activity. They need to communicate with robots, automated guided vehicles, and in fact, it needs to talk with operators, supervisors, and even to the management level, they need to talk. That way, the entire master controller room people will be able to monitor, and sometimes wherever the specific requirements are there, it will go to the maintenance engineer, and then wherever the information goes to suppliers, that information also it goes. Hope you can see here all the machines, somehow the data is pushing. It can be through wide or wireless. That's why this is a you can see here the data flow. From the machine, you can get the live machine monitoring. You can also see the red color, that is basically the alarms and warnings it can be given. With this, I just finished what we are doing under smart manufacturing demonstration and development cell. Now I'll move to the topic on smart manufacturing technologies. Before I get into the smart manufacturing technologies, very short introduction I'll give what is this Industry 4.0. Industry 1.0, basically with the help of water and steam. And in Industry 2.0, it is purely the mass production has evolved with the help of electricity. In Industry 3.0, it is the Industrial Revolution 3.0, where programmable logic controllers, this electronics had picked up somewhere in 1980s. In Industry Revolution 4.0, people are talking about this cyber physical systems. That is where the level of complexity, what you can see, the commonality in all these industry revolutions, only the level of complexity is keep increasing. Today, the vision of Industry 4.0, till the humans are replaced by robots and take autonomous decisions, the Industry 4.0 will continue till that time. What are the benefits you get it when you implement this Industry 4.0? One is you can able to save the cost, you can reduce the cost of your production, and you can also get total customer satisfaction. You can make your products fast and then make it cheap, and the quality also can be improved. And when you adopt this Industry 4.0, the complex products can be able to develop. You can see whatever products you are buying today for household or even for industrial requirements, it has a lot of features that shows that the complexity has increased, and if you want to be globally competitive, you need to adopt this industry 4.0. And then when it comes to manufacturing industries, the benefits are basically the productivity, the overall equipment efficiency of their factories can be improved, and then quality of the product also can be improved. Then the flexibility in their operations. Earlier days, if you take Maruti, they were coming with one or two models because of a restriction with respect to their line of manufacturing as well as assembly lines. But today, the same assembly line is flexible to use it for more varieties of products. Okay, that way you see that the products, what comes out from Maruti has been increased because of this flexibility, because thanks to these robots and AGVs and then flexible manufacturing systems, because of those it is able to get a lot of benefits, all these industries. And coming to the speed of market, earlier days, if you can recall 10 years back, any car manufacturer is releasing the design. He is able to get the product after 1 year. But today, the scenario has completely changed. If the design is ready within 1 month or 2 months, the product should be available to the market. That time to the market is very high. That way, the opportunities can be exponentially increases. And what are these technologies? When I say smart manufacturing technologies, these are the 9 pillars of technologies. Whichever technologies you are using it for manufacturing applications, you can say that your factory or your workshop or industry 4.0 enabled. Okay. What are those technologies? One is autonomous robots. As I mentioned that earlier, people were using robots only for productivity requirements, but today the robot, it should not just do the productivity job, it should able to take the autonomous decisions. Then the big data analytics, as you know that once you get the data from your factory, you should do proper analytics, otherwise you will not able to come out with any business models. And then this supply chain is one of the important activity for this smart manufacturing. This is also part of supply chain has become very integral part of it. Then additive manufacturing, as I mentioned, time to market, if you want to get in, this additive manufacturing is going to play a crucial role in the coming futures. And even some of the industries like aerospace already adopted this technology, but it is a long way to go. It is going to be the disruptive technology for the coming future. And then cloud-based technologies. I think all we are connected today with the cloud services, because having hardware with you, it will be very expensive. With a very nominal charge, we are able to connect with each other. And in fact, with a small application like Cisco, we are able to communicate with you at a very nominal cost, thanks to these cloud services. And then the cyber security, people were worried about the security, but today a lot of organizations had come and then even in fact, thanks to this blockchain technology, a lot of security is able to provide for all these solutions, because all this requires some kind of open connectivity. There is a chance of misusing the data, but there are some technologies which can able to help for this cyber security. And then industrial Internet of Things. I think people may be knowing about how Internet of Things has been evolved. All these multinationals, how they are doing. If the same Internet of Things can be used for industrial requirements, we call it as industrial Internet of Things. And then horizontal and vertical integration. This is also a part of this smart manufacturing, without which you cannot able to communicate across the systems. Then augmented reality and virtual reality. This is playing a crucial role for training and maintenance activities in manufacturing industries. When you go to industries like Maruti, they will have so many technicians. You cannot have every time manual training. With the help of virtual reality and augmented reality, you can able to train them, and they can also make use of these technologies for maintenance. All these technologies are part of this smart manufacturing. Okay, now when I say machine to machine connectivity, it is basically a communication When I say machine to machine connectivity, it is basically a communication method where it comes under this horizontal and vertical integration. Hope it is clear where this machine to machine communication is coming. It is a part of this horizontal and vertical integration. And today, whenever we conduct the program, all the time people were asking the return of investments or the value proportion from this industry 4.0. Even though I say that industry 4.0 is not a technology and you can adopt in the factory with a simple hardware, but people always look at the return of investments. Okay, there is that I would like to answer with this slide. The first thing what you should understand is after adopting this industry 4.0, you may not able to increase your productivity drastically. And of course, the value return on investments of the investment, what you do, you may not able to get immediately, but you will get it once you evolve. Once you get your factory evolved to this industry 4.0 vision, there you can able to really see the value. What is the staged approach? Let us see. There are basically 4 stages are there to reach the actual vision and get the complete value benefits. The first stage is, if you look at 2015, there was a survey by Cisco. 95% of the Indian machines, basically all the factories, if you take, they were not connected to each other. That shows that what is happening in the factory, you don't have any information. That way, you cannot do any value addition for that in 2015. But today, people are aware about this technology. At least 60% of the machines are connected. It means India is somewhere in the stage 1. They are able to get the data with the help of machine connectivity protocols, or they are taking some support from startup companies. With that, they could able to connect and see what is happening in the factory. This is the first stage. I think majority of the industries are in what is happening in their factory, they are able to get it. Now, there are some industries like Siemens, such companies in India I'm talking about, they could able to convert their data into a knowledge. That is where you'll get to know why is it happening. In the first stage, you'll get to know what is happening so that you can see the data. In the second stage, you are converting your data, that is information, into a knowledge. That is where all people are talking about analytics, big data analytics. There you'll get to know why is it happening. Then you can understand it. Okay, once you understand, then you can able to predict for the future. That is where what will happen in the future, so that you can be prepared for tomorrow. With the help of AI and ML techniques, you can able to predict. Just by having a prediction, that is not sufficient. You need to convert this predictions or forecast, that is a knowledge, to wisdom. You need to convert that wisdom into an autonomous decisions. You need to take it. That is, then only this industry 4.0 vision will be done. These autonomous actions, once the factories, the smart factories takes autonomously, then you can see the real value in terms of return of investments. Till that time, you will be seeing very small benefits. But once you reach to this stage 4, that is where your factory takes decisions, then you can see the real value. And this industry 4.0, one good thing about this technology is everything is open. That is where if the product is not open, then all these manufacturing industries are not accepting their products to their factory. That shows that interoperability has become a common feature, and it has become a common language wherein you can able to comfortably make use of their products for your requirements. What it says that there is an industry 4.0, it for a common language purpose, they call it as a RAM, that is a reference architecture model for industry 4.0. All the products whichever you use, they should be having this kind of architecture, so that you can able to communicate from the machines, your actuators and sensors, the edge connectivity, then device management, then the IT layer, basically data service, analytical service, Then applications, in turn, you can use it for business applications, in turn for business systems. This all you need to be connected to each other, both vertically and whatever you use, they should have some software defined infrastructure. The connectivity should be established, and then security should be there. All that, if it is possible, then you can accept those products when they adopt these architectures. This is a slide where basically you need to understand all these companies today. They will be, if you want to implement these layers, you need to able to manage. I mean, so you will be buying machines from OEMs, and when you are talking with a OEM like CNC machines, when you are buying, these physical systems are nothing but CNC machines, then your robots and cobots, then automated guided vehicles. Those will be driven with the help of sensors and actuators. Those sensors and actuators will be driven with controllers, basically PLCs or some motion controller. Those should have edge connectivity, so that and also sometimes you need to do high speed analytics. There the edge computing should happen at the edge level, and then these people should able to communicate with IT service, that is a data service. There you can able to take the data from the machine, and then they can do some models here like A and ML, so that models can be used for some applications like maintenance, monitoring, control. Such thing can be done. In turn, the business can be improved. Whatever you are using the service, you see that all these layers you are able to connect to each other, then you can see the real benefits. That is the architecture it shows. Now I'll get into the actual topic, that is the machine-to-machine connectivity and its applications in metal cutting. What is this machine-to-machine? Machine-to-machine refers to networking of machines for the purpose of remote monitoring, control, and data exchange. Okay, machine to machine is mainly used for remote control, and you can also do remote monitoring, and you can also exchange the information. But you can see here, this is a machine to machine area network where the machines are able to communicate to each other, and this is the outside world. To take the machine to machine area to the core network, you need to use some gateways. And then you have another area, there the robots are able to communicate to each other with the help of M2M again. Then you can use either wide or wireless network, so that you can use it for remote applications. This is your remote application. If you want to take the data from M2M area, you need to have M2M connectivity. That is, I will be showing what are those connectivities in the coming slides. And in order to meet with the outside world, like wide or wireless networks, you need to have some M2M gateways. And then with the help of this wide and wireless communication, you can wide generally use it for local on-premises applications, and wireless you can use it across the world, so that you can use it for remote control and remote monitoring, and you can also exchange the data across the globe. This is a complete overview of M2M, how it looks. Now, what is this M2M? Basically, M2M, it consists of basically machines, or you can call it as M2M nodes, which will have embedded hardware, mainly for sensing, actuation, and communication. And what are the protocols generally in M2M they use are local area networks like Zigbee, Bluetooth, Modbus, then wireless Modbus, power line communication, and then internet protocols. The communication networks provides connectivity to remote M2M areas. And then you can also, as I mentioned in the previous slide, with the help of wide and wireless networks, you can make that into proprietary protocols. As I mentioned, generally the M2M, they use Bluetooth, Zigbee, all this. Now, if you want to make, because the M2M can be a proprietary or non-proprietary protocols, but to make that into a proprietary, you can use the M2M gateway. wherein all this M2M communication, they will take into a native protocol. From there, you will be using some protocol conversions. With that protocol translation, you can make it a proxy. That is where the proprietary protocols you can IP-based protocol you can make it. With the help of IP routing, you can use it across the globe. You require M2M gateway to convert non-IP based protocol into IP based protocol. Then what is the difference when I say that M2M and IoT, finally both are taking data to the cloud? People always have a doubt. What is the difference between M2M and IoT? One thing you need to understand, these are the 5 points I am explaining the differences. The one is the communication protocol. M2M uses either IP based or non-IP based, but when in case of IoT, it will be only IP based protocols. And in M2M, basically when you say communication, it is between machines or between the field devices. And in case of IoT, it is things like home devices basically. And the hardware, in case of M2M, it is mostly like a embedded hardware. In case of IoT, you will be using only the software emphasis. The emphasis will be more on hardware in M2M. The emphasis will be more on software in IoT. And the fourth one is the data collection and analysis. Here in M2M, the data will be collected within the on-premises, whereas IoT, it is in the cloud. And coming to the IoT applications and M2M applications, M2M will be used on-premises remote diagnosis with a limited area. And then you can also use it for service management applications, again within the on-premises. And in case of IoT, you can also use remote diagnostics, but it is across the globe. And it is the enterprise level, you can able to control it. And then again, when we talk about the data flow, basically there is a open system interconnection model. I think people would have studied in computer networks, where there are 7 layers you would have studied. In case of IoT and M2M, people will be mainly used these 4 layers. That is a physical, network, and transport and application layer. Maybe you can get this information in internet. I will try to show where this IoT and M2M is different in the next slide. Here you can see that, as I mentioned, there are 4 layers will be used. That is the physical and link layer, and then network layer, transport layer, and application layer. The M2M will be communicating between these 2 layers, whereas IoT will be communicating within these 2 layers, transport and application layer. This is the main difference. You can see that in case of M2M, the communication will be mainly between Ethernet of one device to other device. Ethernet they will be using, or you can use Wi-Fi, or you can use some internet protocols like IPv4 and IPv6. So with that, you can able to communicate. This is a way for communication in M2M. In case of IoT, they will be using the application layer and the transport layer like HTTP or MQTT. Those protocols will be used. This is a basic understanding. I'm not getting into details. Those who are very much interested in acquiring the data, they can go through a lot of informations are available in internet. And coming to the M2M requirements, because today your factory may have 2 to 3 machines. Tomorrow it may expand to 100 machines. You should always see that the scalability should be there for M2M systems, and then mobility. Then there should not be any errors while reading the data, then logging, and then all this robustness in sending the data. These are the basic requirements whenever you talk about M2M. You need to ensure all these things when you adopt in your factory. What are the general protocols used in manufacturing industries? The popular 2 standards have shown here. One is a OPC UA. The second one is the MT Connect. This OPC UA is widely used, and this MT Connect people are using within the factory. Both are popular standards. When if you see that somewhere in 2000 or before 1996, I think 1996 to 2000, all these manufacturers they were limiting their, I mean, they were not allowing the data to be taken from their devices. Then all the countries they sat together and they discussed about open modular controllers. That is where people started thinking about openness of their systems to the external world. Thanks to this, the OPC Foundation, who are the people who developed this OPC UA. This is a open platform controller unified architecture. It is basically a machine-to-machine communication protocol used for industrial automation. And then even it has become today one of the important specifications for any procurement. You ensure that whatever device you are buying, like machine or robot, see that either OPC or MT Connect communication is there. Then only you can able to make use of those machines and devices for your smart factory. And then what are the roles of OPC UA and MT Connect in the manufacturing industry? It makes your machines into which can be used for smart manufacturing. In smart manufacturing, it also contributes to the reduction of complexity in communication. Earlier days, if you see that there were a lot of communications like Profibus, Fieldbus, Profinet, Modbus, TCP/IP, like that. There were a lot of communications. People were taking a lot of time to read the data. Okay, thanks to these two standards, you don't need to worry much what kind of communication is giving, and as long as he is able to give a OPC server or MT Connect adapter, you can comfortably use this their products in your factory. You don't need to worry about their libraries now. You can directly take. You should have OPC client and their OPC server. You can able to get the data. And you, because of this, you can able to accommodate the legacy machines like old machines and even new machines. And you can product lines like assembly lines where PLCs would be used. All that you can able to easily connect it, and it is a cross-platform. It means you can able to connect PLCs, your motion controllers, or any other hardware which can able to give in the OPC format. You can use this data. And coming to MT Connect, what is this MT Connect? As I mentioned, this is also machine-to-machine protocol, but it works on adapter and agent. In case of OPC, you will have a OPC server and OPC client, whereas in case of MT Connect, you will have an adapter and agent. When you say the device, the devices are something like CNCs or smart sensors or PLC. They should be able to give an adapter to you. That is where your machine builder or controller builder or any third party people can able to give this adapter. With the help of agent, you can able to read the data and you can make your own applications like overall equipment efficiency or machine monitoring or even health monitoring can be done by getting the data. This is applications, user applications will be done for utilizing in their factory. Okay, I just want to say about, I think from now I'll be talking more on OPC. You can also use MT Connect there. Okay, then if you, earlier days, how they were operating before OPC, and I'll be showing after OPC. Earlier days, whatever controllers you are buying, they were having a proprietary protocols. Some people come with a Modbus, some people come with HART drive, HART communication, and some people come with a Profinet. Okay, with that, then every vendor, I mean, every supplier has to give custom drivers to you. And then when you want to integrate for multiple applications, then you need to take data from, like if you take the Modbus for different applications, you need to take to this and you need to take to another application and to other application. What will happen here is the loading will happen on this particular device. Same thing, and then you can see the data here. Lot of connections are there. There is a chance of losing the data. And when it comes, and then coming to after OPC, once this OPC UA had come, now all these vendors are complying to OPC. That shows that they are ready to share their data in a common language, so that the client need not worry about what kind of protocols the vendor is giving. He just has to focus on OPC only. He will have an OPC client. With the help of OPC server, any kind of drivers can able to communicate with OPC server. He will be just focusing on his own requirement with the help of OPC. Hope it is very clear. So here you can see that there is no loading can takes place. I mean, you can connect any number of machines because you are taking the data from the server. There won't be any loading, and you can, the scalability is very high. You can connect 1,000 machines to one machine, no issues. That kind of opportunities are there. And then and today, if you see the distributed system, some you will get with directly, you may get it like IoT connectivity, and here also IoT connectivity. Some you will have a M2M connectivity. With the help of gateways, you can take all these IP based protocol, non-IP based protocols into IP based protocol, so that you can able to take it to the cloud. And then from here also you can take it to the cloud, so that you can use it for remote control and monitoring. You can do it. And the fundamental, I think in case of OPC and MT Connect, in OPC you can use it for both read and write. In case of MT Connect, you can only read the data. It means you can able to, in OPC you can use it for remote control and remote monitoring, where in case of MT Connect you can only use it for remote monitoring. And look at the industries. All the industries like IT, engineering, then general industries, process automation, IO level applications, then factory automation, energy, consortia, any associations, all these people are accepting this OPC standard. This has become an industrial interoperability standard. Okay, this is the basic awareness we wanted to give you. Whenever you are buying a product, you see that that product has a OPC UA communication. Or if you can able to, if they give a OPC server, you can able to do whatever you want to do with that machine. Okay. Because earlier days, if you want to develop one application, reading the data through EtherCAT is become a complex task. Or if you want to read the data from PowerLink, only the integrators were able to do it. But today the users can able to make their own applications because of this OPC UA. You no need to worry about this integration of all these devices for your requirements. All OPC UA will be taken care. And what are the applications? I have finished the basic understanding of machine-to-machine connectivity. Now I'll be showing the applications of machine-to-machine connectivity, mainly for metal cutting. I think I'll be showing mainly on CNC machines data. You can see the picture here. There is a machine, and you will have a CNC controller. It could be from Siemens or Fanuc or Heidenheim. All these people will have a OPC. With the help of OPC, you can able to get the machine information, and you can also control the machine remotely, and you'll also get alarm messages. All that you can able to get it. But the basic limitation with this communication is you can only take the action at every 0.5 second. Okay, if you want to control the machine, it can only possible with a delay of 0.5 second. Okay, that is the fundamental limitation with any machine-to-machine protocols. Then if the applications are very critical, like accident prevention, or if you want to do some kind of health monitoring of your machines, then you cannot be able to use this machine-to-machine connectivity protocols. You have to have a high-speed hardware wherein with the help of external sensors, you can able to take action That is where I have shown the microcontroller. This is a microcontroller where it can. There is a noise from someone. Ajit. Ajit sir, can you please mute yourself? Sushma, can you please mute him? And you can see here, as I mentioned, the limitation with the machine-to-machine protocols are you can able to get the data with a latency of 0.5 seconds. And when it comes to the high-speed applications like health monitoring or condition-based monitoring, or you want to do some structural-based requirements, or even accident prevention in CNC machines, because the speed at which they use in automobiles will be huge. There you cannot able to take decisions quickly. For that, you need to have a high-speed embedded controller wherein you can able to read the data like a vibration sensor or acoustic sensor. In turn, you can able to stop the machine with the help of machine-to-machine connectivity. Okay, this is the architecture we have shown. What is the benefit with the benefit from M2M is you can get complete machine information. I think Mr. Nabil will be showing what and all information we get it from the machine. Almost 5,500 parameters you can get from the machine. But all these 5,500 parameters may not be useful to you. Majority you need to use it and make your own dashboards. It depends on the requirement of your company. Generally, you will get alarms. You will also get some kind of torque, spindle current. Those informations you can get. You can also read part programs remotely, and you can also control your feed. Like you can override functions wherever it is there, like feed rate override or spindle override. Those can be controlled remotely with the help of M2M, but with the limitation of 0.5 seconds. The other benefit with the other technique is where you can able to, if you want to do some kind of condition monitoring, I think this is a very important subject, condition-based monitoring, and also accident prevention. That is where the machine will get into breakdown. If you can able to develop some modules for condition-based monitoring and accident prevention, then the company will be very much benefited. Then majority of the people who are not aware about the limitations, they want to use the still M2M there. You cannot able to do condition-based monitoring and accident prevention with M2M. That is what I wanted to highlight here. For that, you have to use some external sensors like acoustics or vibration sensors, and you should use some embedded controller. And with the help of M2M, you can able to stop it, the machine. You can send the emergency signal to that so that you can stop the machine. And this speed would be in 250 milliseconds. Okay, you can yeah, in 250 milliseconds, you can able to stop the machine. Okay, I'll show you in the coming slide. Now I'll be demonstrating you few modules. Okay, with the help of machine-to-machine connectivity, we are getting the data. How we can use this data for multiple applications. One is for process monitoring. The second one is for toolbar monitoring. And then the third one is for adaptive feed control. And then fourth one is the collision detection. And finally, the condition-based monitoring. All these solutions I will be showing with the help of M2M and one with external sensor. In case of process monitoring, here you can see that just by reading the torque parameter, spindle torque, if you can read, I think there are some people from automobile industries today, they're attending like Sansera engineering. Those people know the value of, because they produce a lot of automobile components. For them, every second matters. For those people, generally, as it is automobile component, generally they take 5 to 10 seconds as for one component. For producing one component, generally they take 5 to 10 seconds. Then if you can able to read that 10 seconds information, like 10 times, 10 cycles, if you can able to get the data, by getting the 10 cycles of information, you can able to predict or you can able to evaluate your upper threshold and lower threshold. Now, with the help of this torque parameter and reading of 10 cycles, you can able to get these values like upper threshold and lower threshold. As long as the process is within these two limits, you can say that the process is okay. That then the operator need not worry, because generally what happens is they will be waiting for the failure, then only they replace the tool. But with this, you can, by setting the thresholds, you can able to comfortably do it without any operator intervention. Okay, this we will be demonstrating. And then coming to toolware monitoring, in most of the production organization, again like Sansera kind of organizations, what they generally do is, with the help of their expertise, experienced people, they know that how long the cutting tool can be used for this particular components. Generally, like they will have an understanding like 1,000 components it can able to produce. After 1,000 cycles, they will be replacing it. But there are chances that this tool can be able to continue to use it. Okay, for that reason, with the help of this M2M, where again you read the torque, average torque, you read it, as long as within this threshold like 17.5, then you can able to continue to use it. You see, in case of here, it has reached at somewhere at some 750, where in case of this application, the tool continue to do it even after 1,000 processes. Still, the tool can continue to use it for some more number of components, like another 500. This, with experience, generally people they replace somewhere at 600 or 700, but with the help of this just torque information, and you can able to have the data, this you can see here, tool reserve, till it reaches 17.5 Newton meter, the tool can continue to work. Okay, the life of the tool can be enhanced. I mean, you can effectively take the decisions with this kind of history of data. Hope it is clear. Then the third one, these two applications are basically a monitoring, but monitoring for process, and the second one is for monitoring of tool wear condition, and the third one is mainly a requirement of a control. If you want to control the machine, then as I said, there is a possibilities of feed control and spindle override control. In such cases, what we need to put a threshold for the torque again, where you can continue to use your override functions up to 130%. Now you see that once your torque reaches beyond this 1.2 Newton meter, then the override, the feed override should be reduced. Now from 130%, as you see that the torque when it has reached from here to here 1.2, then suddenly the override function also should reduce it so that it will come within the limit. Okay, that way you can able to optimize your process, and this is the best combination. You can use it for the machine. One, you can get the productivity, and you can also safeguard the tool with this feature. The same model, if you use it, so you can see here again, if you want to protect the tool, you set a torque limit as a 3 Newton meter in this case. If you know that your tool is able to properly work till 3 Newton meter, then you set that as a threshold. Once it reaches to 3 Newton meter, then you can reduce the override from 105 to 85%. You can see that drastically, once you reduce the feed, the tool, the torque, what it experiences by the spindle will reduce drastically. That way you can protect the tool, you can use it for a longer duration. Okay, here the compromise is, one is the productivity should be more, and at the same time we want to effectively utilize the tool wear, so that you can able to reduce the cost of your product. Okay, these are the few applications I wanted to show. Now I'll be showing a few, whatever we have developed, I'll show it to you here. I think those who wanted to see what smart manufacturing solutions we have developed solutions related to energy monitoring. This energy monitoring, we can use it for multiple applications. With respect to machine connectivity, we have developed three modules. One is the overall equipment efficiency. Then we also developed a few dashboards which are required for operator, supervisor, and the maintenance engineers. And then we also developed one module for process monitoring, mainly keeping in mind automobile companies, automobile component manufacturers. And then we also, as you know, that a lot of legacy machines are there in the country, how to make them smart, that demonstration also we have done here. Now, as our topic is mainly on machine-to-machine connectivity, I will be showing only these three solutions. In case of OEE, overall equipment efficiency, I just click it. You can see here. I think today's this is not today's data. Let me check today's data. Okay, this is the today's data. The OEE, it shows 21.17. Then you can see that the availability, I mean, we generally work from 8:30 to 5. I think he would have switched on only for 21% of the time from morning. And then whatever it does, we developed an algorithm inside. There you can see the performance and quality. And you can also see how many parts have been rejected. Then what are the OE losses percentage, all that it will be showing here. Then you can also see the OE losses. Here you can see here, this is the actual data. It has come from the morning. Today's data, I think he did not run here. He has taken the break for almost 68 minutes, and he ran only for 15 minutes and 15 minutes. I think two components only he has produced. All that information you can able to see it, and in the same thing you can see from morning 8 o'clock to now, almost 3 hours, out of which only 30 minutes he ran the machine, and then he has taken some time for setting, and then before start it is, and then he has taken the break of almost 100 minutes. Okay, as I think it is not a production environment, we don't continuously run our machines. Okay, this is one of the module. With the help of machine-to-machine connectivity, we are getting the complete machine information. With that, we could able to do the overall equipment efficiency of one machine. Okay, with this model, you can expand to your entire factory also. Okay. The second application is a process monitoring. In process monitoring, you can select the machine, and you can also, because it is a kind of teaching also, you need to do it. For that, you need to specify what process that company is doing now, or that machine it is doing, and then what is the number of seconds it is taking to complete one job. Let us take only 5 seconds. Then if you want to build the model, you need to give number of cycles also, so that with that data, it can able to build the model. Then I'm giving some 6 cycles I'll give. Now, as I said, for every 5 seconds, the data is captured for 6 samples. Now it has been calculated. The algorithm has calculated what could be the upper threshold and what could be the lower threshold. Now, as long as the live data is falling within this upper and lower threshold, the operator can continue to use it. And once it shows the status as bad, he has to stop the process, and he has to look for the reasons, whether tool has gone bad, whether coolant is going properly or not. All that you can able to see. This module very useful for automobile component manufacturers, where they can use it for process monitoring. I'll stop the process. Then we also developed a few dashboards which can be used again with the help of machine-to-machine connectivity. All we have used OPC UA communication for these developments. You can see that a machine, what program it is running, you can see, and then what is the status of the machine at the moment. Then what are the overrides here, and where this axis is commanded or current positions it is showing. All that it is showing here. This is mainly for the we kept the operator in mind, and we developed this. This is for the operator dashboard. Likewise, for a maintenance engineer, he will be more worried about what alarms and messages are coming from the machine. This continuously he can able to monitor, and he can able to take a decision. Okay, some maybe quick decisions has to be taken, some slowly he can take it. Based on that, he can plan for the maintenance activities. Okay, the next, okay, this, okay, then the third one is those who are OEMs. Sometimes internally what is happening you wanted to know. There they can use this diagnostic module, because as I said, with OPC you will get all parameters from the machine. For OEM like this DMG, those people, they want to evaluate what is happening inside. They can able to use this dashboard and can able to cross check what has gone inside, what has happened inside. And then when it comes to supervisor will not bother about what part program it is running. He will be more bothered about how much productivity has been happened today for his factory. This is the layout we have done for our factory. Only for 3 machines at the moment we are showing. I think 1 or 2 will be dummies data also, because there is no provision to get that data with OPC. But this is live data, where he will be more worried about how many parts have been produced and how many bad parts had come, how many are rejected. And it will also show where is the location, then what kind of controller it is using, and it will show the alarm status, and it will also show how much productivity is happening. He will be very happy if the entire day, if it shows green, he will be very happy because the machine is continuously used. Okay, you can also get what programs it is running, who is the operator, because generally in industries, the operator will be changing for every shift. But all that information the supervisor can able to get remotely. Okay, I think these are the 3 solutions we plan to show. If you have any questions, I'll be happy to answer. Otherwise, my presentation is done. Thank you so much. Now, those who are interested to have data flow representation, how we are taking this data and developing these modules, I will be requesting Mr. Nabil to take care. Before that, if you have any questions, I'll be happy to answer. Anyone
Hello?
has questions? Yeah.
Hello? Yeah, so this is Shashank Naik from Imeco Machines.
Yeah, tell me, sir.
Can you please share the screen of IoT and machine-to-machine learning comparison?
Yeah, one second. One second, I'll share the screen.
Yeah, sure.
Sir, which slide should I scroll? Yeah, this is the difference between M2M and IoT. And I also shown this is the main difference I would like to highlight.
Yeah, the previous one.
This there is no difference as such. This is basically I just want to give a touch on what is this OSI. I wanted to show to the people. For that reason, I pulled
Can
this.
you go one more slide behind?
Yeah.
Yeah, this one.
Yes.
Just a minute. Yes, sir, yeah, got it. Thank you. So
Yeah.
just to introduce ourselves, we are a manufacturers of industrial cleaning machines.
Okay.
And basically industrial cleaning machines are a cleaning of different components on an industrial scale.
Okay.
Basically you can consider something like a gear after the gear has been machined.
Yes. Yes. There is a disturbance from your end, sir. The voice is not there now. Sir, if it is questions are not there, we can discuss offline.
Hello?
Shall we discuss offline regarding your discussion? Hello.
Thank you.
Yeah, I'll provide you my details in chat box. We will discuss offline because a lot of other people are there.
Sure,
May not
sure.
of their interest. Yes.
Yes.
Yes. How about others? If you have any questions, we can discuss. Otherwise, I request my colleague, Mr. Nabil, to present now. Is that okay?
Sir, hello, sir. I'm Vijayanand,
Yeah.
sir, from PSG Tech, sir.
Yeah, tell me, sir.
So this overall equipment effectiveness, sir. So what is
Yes,
the
sir.
duration in which that is being calculated, sir? OEE.
No, OEE
Like
we have
for
taken.
every shift
No,
basis, this data which is available right now, you showcased. It is on
yes,
shift
sir.
basis
Sir,
or
actually, yeah, sir, I'll answer your question. I got your point. See, OE depends on the industry, how they work. Some people work 3 shifts, some people work 2 shifts, some people work only 1 shift. Okay, it all depends on what you need to be considered, like breaks, how should be considered. It is left to the industry user basically. Based on that, you need to design or optimize that solution based on his requirement. You can make the module. Okay, now CMTA we work only 1 shift, that is 8:38 to 5 o'clock we take as a OEE, and then we calculate accordingly.
okay, sir. Thank you, sir.
Yes. Any other questions, sir?
Hello, sir. Hello.
Sir, tell me.
Yeah. So at current, the OPCA can be installed along with the other communication protocol. Like if the machine is already been installed with other proprietary communication protocol,
Yeah,
can
yes, sir.
OPCA
Yes,
be?
yes, sir.
It could be able to
Yes, it
install,
is
right?
possible. Yes, it is possible. What you have to do is, if the OPC is not able to take directly, sir, can you mute yourself because there is an echo. Sir, with any protocol, you can able to convert into OPC. Only thing is you need to use some kind of protocol converters are available in the market. You use those protocol converters, then you can take to OPC format. Did I
Okay,
answer?
so yeah, so which means you're saying like we need to have a separate adapter for that.
Yes,
OPC adapter.
Yes.
Yeah. Okay. Yeah. Thank you.
Yes. Any other questions? If we don't have any questions, I request Nabil. Are you there?
Yes, sir.
Please proceed, Nabil. He will be basically showing because there were some requests from the participants. All the time we are only giving presentations. We are not actually showing the right work because I think why we are not showing the right work is that may not be the interest to the participants. That's why we are not showing. We are open to show all the works what we are doing. Now I request Nabil to show the data flow, how we are getting the data from OPC, and then from there, how we are developing it. All the steps you please show, Nabil. Nabil?
Yeah. Sharing it. Hello, myself is Nabil. I'll be discussing how the OPCA communication and how the data flow work of OPCA is happening. For basic communication, you need an OPCA server and OPCA client. Then OPCA server is a software which will collect all the data behind the machine. So it's for the simple our Mazak machine, if you want the temperature or current data, if you have installed OPCA server, what it will do is it will continuously collect the data and it will store that. For to use to get the data, we need an OPCA client. With these two components only, we can collect the data. For the machine, if they have inbuilt OPCA server, we only need an OPCA client to collect the data. If the machine is not providing, if the vendor is not providing OPCA server, we have to make our own. For example, the OPCA client's communication is a client server. So to get the data, first you have to ask for it. That is the OPCA client. First, while connecting, OPCA client asks for the communication, how to connect it. Then it will, after the communication, they will ask for the nodes. That is, what are the parameters they can read. For example, I can show you. One example, I will. This is the OPCA client I'm using. This is the Unified Automation Expert. This is the OPCA client. It is open for it. For this example, if you click here, if you see the numeric server, that is the client server we are connecting. In this thing, we can see.
One moment, I just tell them. This is a Siemens controller data we are reading. For that, the Siemens people have to give the server. Once he provides the server with the help of OPC client, he is getting all this data.
Okay, this is a OPC client. We are in the website. There is an open OPC client server. This is one of the client I downloaded. With this thing, we can see what are the parameters available for it. For example, this is a Siemens controller. From this Siemens controller, these are all the parameters available. According to OPCA standards, all the data communication is in like hierarchical structure, like it folder inside a folder. For everything related to access will be inside this section, and everything related to drive will be inside this section. So from this, we can see what are the parameters available for OPCA. And for reading the OPCA, we have two methods. First is directly reading, and another is subscribing. For example, this thing in here, the data access view, we can see the cycle time, display name, cycle time. This is the one we are accessing. So in this thing, we have already completed 2 cycles. That's why the value is constant. So if you check the operating time, it is constant. It is also constant because this is the start, from the start time, how much it is changing. And now if you check the sum cycle time, this is an average of this time. So if you subscribe to that, it will be constant. Whenever value changes, it will update it. Likewise, we can read how much parts we produce, that is 2. From this node ID, we can read what are the parts, what are the values we are available. For different machines, different node IDs are available. So this is only for our Siemens controller. They have provided the documentation. From this thing, we got the node ID. For different machine, this will be different node ID. From that, we have to find the node IDs and the values, whether it is accessible and whether it is available. This is how you'll read the values. Now for the in OPCA, there's another option for getting the alarms and events. If any new alarms or event is happening, it will inform us this is happened. That is the event view. For this thing, OPCA is providing when is the alarm happen, what is the severity, which is the object, and what is the source name. These things are provided by the OPCA because OPCA is a standard structure for data exchange. For this standardization, they have said we have to provide all this information. And this is just a client application. What we can see is whatever it is, whatever it is they are providing. This is just a point of we are reading. But if you want to send to cloud, or if you want to send to other local database or dashboard, we cannot use this thing. We have to create our own application because this is only we are seeing. We are not storing anywhere, or we are not using this. And for if you want to send the data, we have to use our own client for this thing. If it is OPCA client, will be running this application in our local PC or whichever connected to machine. From there, we can send to cloud database, local database, or live dashboard. Then only this data will be stored. Next thing is, what are the options for implementing this data client, that client application? For OPC implement, it's the open source implementation. So we can see there is a lot of resources for it. For each language, they are providing client and servers for it. So we are using our C# library for creating the client and sending the data. From these things, we can collect what are the parameters available. As we see in the client application, we can find the access position, feed rate, what are the total parts, operating time, cycle time, running program, alarms and event, spindle speed. From these speeds, these things we can collect and send it to database. And one of the examples from this, whatever we have done is this dashboard. This is a dashboard we created using the values we collected from the OPCA. As you can see, the part program, stop, and MDI mode, spindle overload, feed override. These are all the values from OPCA, and we are sending to database. From that database, we are showing the dashboard value. And for this, if you want these things, you want x-axis, feed rate, x-axis position. Since it is stored in the database, we can see what is happening from this thing. Last 20 seconds, what are the values? In our normal OPC client, it is just showing what I will show you. In unified automation, here we are only just seeing the values, not storing anywhere. For that, after only storing these things, we can use this to make the dashboards. That's it. That is the how we are collecting and sending to database. For this thing, OPC client is required. For the machine, if you already have an OPC server, then we only need to make an OPC client to send the data. If the OPC server is not available for the machine, then we have to create our own OPC server or other vendors there. They will provide. We have to connect the sensors data with them. With this thing, we can collect the machine information. This is how we are doing in CMTI and making the dashboards.
Thank you, Nabil.
Yeah.
Do you have any questions? If we don't have any questions, I thank all the participants for patient listening. And there were a few questions regarding e-certificates. We'll definitely give the e-certificates. I think we would have missed one or two events, but we will be giving shortly because there were some internal limitations. Because of that, we could not able to send it. Last 3 events, I think now we have uploaded. Most likely by today or tomorrow, you will be getting last 2 events. And this feedback form, mostly in a 1 week time, you will be getting, certificates. In a 1 week time, you will be getting for today's event. If you don't have any questions, once again, I thank all the participants for their patient listening. And we are happy to collaborate. Hello.
Hello, sir. Where we can learn do you provide any trainings for learning this IoT implementations?
Sir, IoT, sir, we started very from basic level. We were new to this smart manufacturing.
Okay.
We were continuously learning, and we are doing these programs. We are sharing all the information, whatever we know, all in webinars or through training programs. And in fact, in the future, in 1 or 2 months' time, we'll be calling the MSME industries and even academic institutes to have a hands-on sessions on this Industry 4.0. And there are a lot of open source literatures available. Once you know what you are going to do it, then you will get all the information. And then wherever you find difficulty, you please reach us. If you know, we tell. We don't know, we can also tell that there are other Samarth centers like IISc, IIT Delhi and IIT Kharagpur. You can please reach to them also. They will support you.
Okay.
Yes. Thank you once again. See you in the next webinar.